Hi, Mr. Moss.
Hey guys.
Hi. Uh, we're the Nashua School South AI Club, and it's a pleasure to talk to you. Um, really interested in the work that you do and want to learn more about AI and stuff like that. So, just wondering if you could tell us a little bit about what you do and yeah, stuff like that.
Sure. Yeah. And you guys can call me Robert. Keep it informal too. Yeah. So I'm actually from Rockport, Massachusetts, so the North Shore, not too far away from you guys. But I went to Wentworth Institute of Technology for undergrad, studied computer science, and minored in physics. And then I worked at MIT and Lincoln Laboratory for about 7 years on an aircraft collision avoidance system. So this is an onboard system that will tell a pilot whether to climb or descend away from a potential midair collision. And those use some AI related techniques in order to handle a lot of the data that's happening in terms of all of the GPS data on how to like track aircraft and how do you make a decision in this really complex, uncertain environment. And so then that led me to Stanford, which is where I'm at right now. I got my master's in 2021 in AI, focusing on AI safety. So, these systems which are becoming increasingly popular, they're put in these safety critical situations, just like aircraft collision avoidance. And how do you ensure that they're safe, right? How do you make sure that the decisions that they recommend or autonomous decisions that they actually follow are going to be safe? And so a lot of my research focuses around kind of that safety validation. And then more so right now, I'm focused on how do you plan in uncertain environments? So how do you make decisions over these long horizons in order to make safe decisions? Yeah, so kind of broadly into two different buckets is AI safety and then long horizon planning is really what I'm focused on.
Fantastic. And we think that's really interesting. So about the aircraft, like how you detect if the crash is going to happen or not, how would you create a program like that? That seems really
Yeah,
interesting.
so it's we use kind of this mathematical framework called a partially observable Markov decision process, which is sort of a jargon term to say it's a way to like formally frame a sequential decision making process so that you can solve it pretty efficiently. I actually have like I'm not sure the setup if it's easy to see slides, but I have like a really quick introduction of that. But the idea is you're really just setting up the problem so that like the state of the world and what actions to take and what rewards you get. It's closely related to reinforcement learning, and this way you can interact with your like simulated environment to understand. Okay, I want to avoid collisions, so I want to simulate a bunch of cases in order to avoid those collisions, and then learn how to and learn in what situations I need to make those decisions. So it's through a lot of design on the problem. Like you want to focus on separating kind of the problem formulation from the solution. A lot of times you just focus on the solution, like what algorithm do you need to solve it or something. But here we try to focus on splitting up. Okay, there's a whole problem with how much sensor information do we need? How do you track where the aircraft are going? How do you understand where they are once you have those observations of the world? What actions do the aircraft need to take and at what time? And you try to learn all of that without hand coding it. So every flight you've taken actually has an onboard collision avoidance system, but most of those rules are just that they're rules. It's if altitude is within 300 feet, do this. If your vertical rate is, within 200 feet per minute, do this. So there's a lot of handcrafted rules where we're trying to redesign it so that you can sort of optimize it without kind of the human input in a way. So you just throw a bunch of data at it and make it learn from that.
I see, I see. And so how many people would be a part of making this type of program and what type of rules would there be?
Yeah, so I worked at MIT Lincoln Laboratory with probably about 20 people on the core team. But we also were research sponsored by the FAA, which itself was maybe a dozen or so people. And then we work with an international aviation organization that themselves have industry partners, government partners, and academia. So I'd say in total, the team was probably a little less than 100, but the core design team and development team that made everything was probably about 12 of us. And so I had the pleasure to be a core contributor to that kind of small team.
Okay, thank you so much. That's it for me. My name is Shureisha. I'm a sophomore at Nashua South. Mihir wants to go next.
Cool. Yeah.
Hi, Robert. I was Mihir. I'm president. I was emailing you. So
Awesome.
what makes that stuff that you were just talking about different from just like a series of if statements, like all that AI? What makes it different than like if statements? Because you were talking about reinforcement learning. How does that learning make it different than just hand-coded rules, stuff like that?
Yeah. So I think the biggest difference is if you just have a series of if statements, this can get extremely complex, and more so, it can be hard to design. If you're sitting there and you have to make all the decisions on, what conditions need to be met for what decision needs to be made, this could sort of blow up exponentially in terms of like what you have to do to program that. There are some kind of classical AI techniques that do, in fact, operate just as conditionals, just as if statements. But the idea here is you're doing like a decision tree. So at a specific decision, you say, do I go left or do I go right? Pretty much a yes or no binary tree. And so those are really just can be encoded as conditions. But the funny part about that too is you're learning the conditions in order to go like yes or no using data. So you're still not hand coding all those decisions. So as an example, like say if there's like a stock investment bot, right? It could make decisions whether to buy or sell based on some threshold, but in order to figure out that threshold, you have to learn it from data. And so it's still at the end of the day sort of encoded as if statements, but it's using data to figure out those thresholds. So I'd say it's short answer, it's extremely difficult to just do it with if statements, if not impossible compared to kind of more modern machine learning techniques.
Yeah, that's really interesting. So I was working on some autonomous systems for water-based vehicles. And one of the issues that we typically ran into was how you can validate that. I know your work was focusing on the validation of that, but as AI has such a black box nature of things and we don't really understand what happens inside of it, how can you other than running, millions and millions of different trials of it, how can you assure people that, it won't fail or in certain situations it won't act out of place?
Yeah, so in short, there's no guarantee on anything. I mean, it's the same for a lot of other kind of problems, but there's two paths you could take. One is if you have a small enough system, say if you have a neural network based system, and if the neural network is small enough, then you can actually use like white box methods, or you can use formal methods to actually provide some, say, property about that system that you want to not violate, and it will guarantee that. But that research is still extremely cutting edge and doesn't scale well to like practical sized neural networks like the ones you see for autonomous driving or like the autonomous water navigation. So a lot of the work that we do and all the work I did with my master's, and right now we're actually writing a textbook on this, is black box validation. So you pretty much black box validation means you can only give inputs into a system and observe outputs. So you don't really know what's happening internally to the system. And the way you stress test that is either by running, millions or billions of different inputs. But the more important part is trying to come up with clever ways to select those inputs, so you're not just trying out every possible input, which in a lot of cases it's a continuous input space, meaning there's an infinite amount of inputs. So of course you can't try them all. And so a lot of the cases, and this was the same work with the FAA for the aircraft collision avoidance, you could actually see the same thing. It wasn't using a neural network, but it was using, related reinforcement learning techniques. And you can ask yourself, okay, how was that validated for safety? And to give you perspective, we developed pretty much, I'd say 95% of the core system in about 1 year. And then it took us 10 years to validate it. And that's cycles with the FAA, that cycles with industry partners, that really, we use real radar data of aircraft encounters. We use synthetic data of really stressing encounters where they're going to collide. We do a lot of testing, and that's pretty much the standard, both in terms of, as a developer, it gives you comfort that the system is going to work in all the situations that you put it in. And for the people who certify this system, they have input into whether or not you're testing the correct thing. So for aviation, it's more of an open, transparent industry where you work with the federal government, you work with your kind of academic partners to stress test these systems. But right now with things like autonomous vehicles, where it's a competition, it can get a little bit tricky because people like Tesla or Waymo or Cruise, if you've seen the news recently, sort of have an incentive to skirt past some safety considerations in order to be first to market, which is really dangerous. So companies like Cruise, which operate out here in San Francisco, recently had their California autonomous license revoked because they hid some safety information from the authorities. Again, I think because they're put in this setting of competition. So short answer, it's you do still run a lot of scenarios to test it on, but the important part is to be very efficient in what scenarios you pick. And one way you can do that is just pick scenarios that you're likely to find in its real operating world, instead of just throwing every scenario at it that it normally would never ever see.
All right, my name is Adi. I had a question on for students who wanted to get involved with AI as a career choice. What advice would you give them?
Yeah,
Yeah,
absolutely.
absolutely.
So I'd say studying computer science is a good way to go. And a lot of people might be turned off from the math side of it. I like math, but I was never a straight A student in high school or in college. I really found that CS or computer science was something I had a passion for. So just taking courses online, getting more involved in the implementation of it. So playing around with, Python models on your computer or coming up with some little programming ideas. I think just getting more experience that way. And it's also a slow, I think there's, I've been in this field for about 12 years now. And I'm still learning more, of course. And as a PhD student, I'm still learning more. So I'd say find some resources online if you're interested right now to take a Python notebook to implement some character recognition using a neural network, or trying to understand AI is such a broad term. A lot of times we use it as just an umbrella term. It includes machine learning, it includes reinforcement learning, it includes your imitation learning. So there's all these different components of it that could be wildly different. It includes large language models, which are more popular now with your ChatGPTs. So there are definitely different subcomponents that it's good to understand that too as you want to get into this field.
Hi, my name is Salam. I'm a junior at Nashua South. I had a question about like future fields in AI that could boom. You talk about AI associated with safety and like aircrafts and automobiles. You think AI safety could be like a bigger industry in the future, or like what industries could AI be a big part of in the future?
Yeah, so I'm definitely a little biased because of my own experience, but AI safety is probably going to be the most important uh, new industry in AI because of the way it's used. So, if it's used to recommend a video on Netflix or a YouTube video, then there's really no need for safety, unless, I mean, even then you could consider, well, make sure it's not recommending like extremely dangerous videos to children, or it's not recommending really bad videos. But when you're talking about using, like, say, language models for legal cases, right, or people using language models for something other than just asking it questions, the biggest concern now, and you'll see a lot of hype in the news, is safety, is making sure that the way in which they're used is correct. So this goes for autonomous vehicles. This goes for anything in aviation. Aviation is still really hesitant to put neural networks on board aircraft because they're still extremely new and they work really slowly. And most of that is because there's a lack of expertise on AI safety. We have a center here at Stanford called the Center for AI Safety, which focuses on this type of research. And the popularity has kind of skyrocketed in the last couple of years because it's so important. So I'd say that's definitely a big industry that's going to grow. And even the recent, I don't know if you follow the news on OpenAI, the company that makes ChatGPT, but the recent CEO was fired by the board, particularly in some disagreements with how they consider safety of ChatGPT. So this is definitely very very poignant and very on the nose right now in the news. It's a good question.
Hi, back to me, sorry. But
Go for it, yeah.
so we're talking about all this high level AI stuff, right? Like detecting plane crashes and all this water-based stuff. I didn't really catch that. But um, how does it, like, can you give us a brief overview on how it works? Like just the basic levels of how it works.
So that's sort of a loaded question, right? And with 6 minutes, that might be hard. I think maybe I'll ask you what types of AI you're interested in. So you have reinforcement learning that learns through interaction with the environment. You have machine learning that learns, how to predict or classify given a target data. And then you have sort of imitation learning, which learns how to imitate some human or some policy. And then you have language models, which, learn how to predict language. Kind of which one of those are you interested in most? And then maybe I can try other ones.
I think the machine learning is really nice because it takes information it already knows and creates new things based on that.
Yeah. So in general, machine learning, the way it works is you have, of course, a huge data set. So imagine you have a data set of animal photos, right? The one of the biggest components of machine learning is called supervised learning, which means you're supervising the data to tell it what the right answer is in order for it to learn that. So you have all these photos of animals, and then you have the right answer. So say there's a dog, and you say dog. There's a cat, they say cat. There's no animal, and so you say no animal, right? So you have millions of these pairs of images with their labels that say what they are, and so you train a neural network, which is, you can just treat it as like a black box. It's this giant network of nodes that have weights in between them, and those weights are things that you can tune. And the idea is you take an image, you pass it through these weighted functions, and then at the end it's going to predict, or rather it's going to output a value for each of those categories that you've set up. So say one of the categories is dog, cat, no animal, cow, right, chicken. Each one of those is going to have some value associated to it. And the value that has the highest is going to be its prediction on what it thinks it's going to be. And so the training process is you give it all of these inputs that are the images, and you tune the weights using optimization algorithms in such a way that it's going to predict the correct output because you know what that output would be. And the way you test this is you split your data between your training set, which you take about 80% of those data points, or the images, and then testing so that it's never seen these other ones, but hopefully it'll like perform well on those 20% that it's never seen. And so the whole kind of magic behind it is it's just you're able to slightly adjust weights so that given some known image and some known output, and you don't show it the output until it makes a guess. You tune those weights for it to predict the output as much as possible. Yeah.
What do you mean by tuning the weights?
Yeah, so you use optimization algorithms. So you might hear things like gradient descent or stochastic gradient descent. What this means is you're adjusting those weight values, like either adding or subtracting an amount to them, towards the direction that minimizes the difference between its output and like the prediction and the target true value. So you sort of use optimization in order to tune or adjust those weight parameters so that those values, which would be considered the loss between the truth and the prediction, is minimized. Yeah.
So it's like teaching a baby how to differentiate colors.
Pretty much.
Right?
I mean, yeah, you're just doing it incrementally. So you're not just completely like adjusting those to get the right answer. You're sort of slowly, incrementally learning, so that you're not overfitting to one image, you're not overfitting to a handful. You're just trying to slightly adjust so that it all kind of comes together at the end of training.
Absolutely, absolutely. I get it. I think we have one question in the back.
So hi, I'm Nikhil, and I was just wondering like how the journey of like what was your most exciting discovery or breakthrough in your AI career, and how like the journey to get there?
Yeah. Oh, that's a good question. I think in short, it was kind of twofold. I'd say one that the combination, like a lot of research is not, all of a sudden you come up with some Newton level thing that, you're going to get a Nobel Prize for. But the idea is you're collaborating with a lot of people on these things and you're basing your ideas off of existing work that then you extend. And so for me, it was the combination of neural networks as a way to like approximate any function and this like tree search algorithm in order to like plan into the future. And the combination of those two things allows you to efficiently plan. So I think for me, that was one of those aha moments. And it just came from seeing research like out in the wild that was similar, but it gave me ideas on like how to incorporate that into my own research.
Thank you.
Yeah.
So I got one last quick question. So AI, right? It's like I think artificial intelligence. So like I'm pretty sure like you typically take inspiration from psychology for stuff like this. How do you utilize like psychology in the work that you do in AI safety, and how do you use that to improve your the validation of algorithms and stuff like that?
Yeah, so I think in short, I myself don't. There's a branch of kind of AI that is more on the inspiration from psychology or neuroscience as well. And sometimes those are called like symbolic systems, or a way to like, how do you represent how humans think? But I will kind of leave you with this: is the term intelligence is still really loosely defined. Just like things like transportation, right? Like a car is a form of transportation, but so is a plane, which doesn't use wheels, it uses jet engines, but so is a bird that flies with wings. So like transportation sort of comes in all different forms. And I think intelligence, what we're finding out, isn't exactly what humans do. Like some animals have intelligence, some, the way you define intelligence is so loose that yes, you can get inspiration from humans because it's sort of the only thing we know, but it's not the like mimicking humans. I don't think is the goal for a lot of people. It's sort of maybe coming up with something that we wouldn't really recognize as intelligence, but upon further inspection, we're sort of redefining what we think intelligence is. So still pretty loosely defined.
Awesome. We appreciate your time a lot. Thank you, Dr. Moss.
Yeah, of course.
So, we appreciate all your time and all your help helping us with some of the questions.
Yeah, of course. And feel free to share my email if anyone has any follow-ups or wants to reach out for anything.
Yep. All right. Thank you. Have a nice day.
Yeah. Bye, everybody.
Bye.